Okay. Do you remember me telling you the story about how I used to help my ex-husband with his linear regressions? And remember how I told you guys that he was excited anytime the slope wasn't zero? Okay, so the null hypothesis in all of these cases is that the slope is zero, meaning that there's no relationship between the two variables. Isn't it great to say there is no relationship between the two variables in three symbols? Because most of the time in stats, you have to say it all out. But this just means there's no relationship. Or you can think about it like the scatter plot is basically just scattered. Does that make sense? And this one was sort of like that. Okay. And then the alternative is B is less than or greater than or not equal to zero, depending on the wording of the problem. And beta, this is the population slope. So this is the slope of the true regression line relating y equals something to x equals something. And alpha is whatever it is. Do you guys have any questions there? I want to remind you that capital B beta is the population slope, so the true slope, and little b is the sample slope, the one that you would get from your data. Okay, plan. This is a t-test for slope beta. And let's see if you guys remember the conditions. What does L stand for? Linear, great. Okay, so just wanna, I'm gonna go back to this resource page in your packet. We already labeled everything almost on it, but I want to remind you, you can either say scatter plot shows a linear pattern. This one's pretty terrible, but I don't really see like a curve. Um, this one is actually better. The residual plot shows no pattern. You don't have to say both of them, just either one. Um, but you can use either one for the linear condition. Okay. What does I stand for? Independent. And that is 10% condition or random assignment. What's N stand for? normal. So I added in this note, you guys remember the chapter 11 test where I didn't want you guys to make a box plot because, first of all, I didn't give you enough information to make a box plot, but I had already made you make a box plot on the other column. So I just said, previous data shows that population is normal with no extreme, no fewer outliers or whatever. So it might be something like that. Because they don't want you to have to do every little thing. In my excitement of teaching, when did I teach this? Tuesday, last Tuesday. I forgot to have you guys label, I don't know if you care. I forgot to have you guys label the normal condition on this little histogram over here on your page. I had you label these. But my pure excitement of teaching, I forgot to have you label that one. Sorry about that. Although I figured we're smart enough in this class to know that that's what that was for, but I looked back at it, I was like, oh man, it's incomplete. What the heck? Mrs. Talbot, you're really falling down on the job over there. How dare thee? I'll leave it up here for the folks who are writing down the other things they didn't write down the other day furiously right now. Okay. E, that was the new one. It's equal SD. SD being standard deviation. And let me just go over what that means again with my two pens. It just means that if I put pens along the top dot and the bottom dot, that they're pretty much scattered evenly in this space and that there's not any pattern where they're getting closer to the line or further from the line or some sort of weird U shape or something like that. Okay. And then the last one is the easiest one. R is random, beautiful. And it could be both, like that crazy CPM problem that we had. Do you guys have any questions about the conditions? Okay. The do step. So I'm going to go back to the yellow sheet and talk about what we're looking at here. We're doing a hypothesis test. So we're finding the standardized test statistic. Standardized test statistic is T in this case. So T equals statistic minus parameter. Okay, statistic is the sample, which would be the sample slope, which is lowercase b. And where are you going to get that from? Yeah, the computer output, the little table. Okay, and then minus parameter. Parameter is the population slope, which is capital B. And it's the same thing in every single one of these problems. What's capital B in all of these problems? 0. So try to make yourself still write it, right? Whatever the sample slope is minus 0 over. Okay, and then standard error of the statistic is standard error of the slope, which also comes from the computer output. So you're going to get little b from the output, big B is 0, and standard error of the slope is also from the output. Let me just show you what numbers those are again. So little b is the one that's next to the variable you're working with. So the top number is A, the bottom number is B, which is convenient for alphabetical order remembering purposes is. And then standard error of the slope is right next to the slope. So it's this guy and this guy. Okay, and then we need the p-value. And we're back to TCDF. In these, you have to remember what the low and the high is. You're going to have to deal with that negative infinity, positive infinity bit. And degrees of freedom is sample size minus 2. And there's something very important I need to teach you. One more thing. That's probably the last thing that I actually need to show you that you wouldn't already know, because I'm pretty sure that you know how to do the conclude, but sometimes, because why not, the regression output would give you T and the p-value already. If you're forced to use these, and I wouldn't use these if I wasn't forced to, I would still do this deal, but it should match. The thing that you need to know here is this p-value is always two-sided. This is the not equal to p-value. So if your null hypothesis is greater than or less than, you have to cut it in half. So this is already times by 2. Do you guys understand what I'm saying? Okay, this p-value is the not equal to, which means it's already internally in the software been times by 2. If you need it for greater than or less than, you have to divide it by 2. Okay, so we're going to make ourselves a note. And I think that that should suggest to you that most of the time your alternative hypotheses are going to be not equal to for these, because that would be the most common, which is why the computer would do that. That doesn't mean it always is, but you should know it's doubled. Okay. Since our p-value of blank. Hold on. So for our example, it's not long, but I did do it on the other side of the page. You guys can decide. The next thing I did was glue in the last bit. So you can go ahead and arts and crafts in the last thing. Sorry, I didn't get the trace. Last arts and crafts thing. That's it. You guys ready for our last example? Um, so, for this last one, we're gonna use the same, page that we were using in our resource, in our packet, same resource page in the packet with the copy situation. This one. So just scooch the sky side. Okay, state. O, beta equals alpha equals. Okay, the hoe is the same every time. The slope is 0. If the slope is 0, that means there's no relationship between them. Nothing interesting is happening. Just a random looking scatter plot. Now you can see the way the problem's worded. It says, does it provide convincing evidence of a relationship? It doesn't say a positive relationship or a negative relationship. It just says a relationship. So that's how you can tell it's not equal to. Does that make sense? So if it said positive relationship, you would greater than, negative relationship would be less than. But it doesn't give you any kind of direction, so not equal to 0. Y was yield per plant in kilograms. And X was fertilizer in grams. And then 0.05. Everybody see where I got my labels from? Got them from the original scatter plot right there. Okay, now on this problem, the plan is going to be very simple. It says assume conditions are met. T test for slope. If you get a problem that says assume conditions are met, you should have like an entire little personal party. Because that's a lot of work. However, just because this is notes, just make yourself a little note that you can find the conditions in your 12.3a notes, just in case you want to see them. We already did them last Tuesday. They would not change at all for the test versus the interval. Just in case you want to reference back to where the conditions were, just in case it didn't say, you can look back to those. I don't think they're hard. I think they're just tedious. Okay. Do. Standardized test statistic is T. T equals statistic minus parameter. Just because we're doing this only a couple of times, let's just write this out. So statistic minus parameter over standard error of the statistic. And I'm going to go back to the problem here. So the statistic was the sample slope was 0.0173. Parameter is 0 because I said that b was 0 up here. Standard error of the slope is right here next to the slope. Those two guys are friends, 0.0094. And then you're going to be dissatisfied with this information. Because, hold on. You're like, why? You just accused me of being dissatisfied and now your calculator's not working. And I really want to know why. You're going to say I'm dissatisfied because you've decided how I'm going to be emotionally. I got 1.84, which is not that exciting except for that it doesn't match this, which is why I said that that's not satisfying. I feel like that should match. And I feel like my answer is much more reasonable than their answer. Because I have Jedi mind tricks already with stats, I can tell that this is a very large value for t, which means that there's definitely a linear relationship. And look at that scatter plot. Does that look definitely linear to you? No. So this is what I'm telling you. I'm telling you, do the math unless you can't. So what I'm saying is don't just go t equals 3.8151, p-value equals 0.006. Just don't do the math. Unless this is all you're given, then use it because that's all you have. But okay, anyway, don't you feel like that should match? Anyone think it should match? I don't know. It's just me. Okay, so you've been living in a wonderful land of chi-square, where the chi-square was always the low and infinity was always the high, but that's not the case with the t-curve. So I've drawn you a curve. It looks normal, but just pretend it's a t-curve. 1.84 is up here. Shade in the tail. What would the low and what would the high be then? The low is 1.84. The high is positive infinity. And how many degrees of freedom do we have in this problem? Anybody remember? It's, yeah, sample size minus 2, so 31. Let's remind ourselves where TCDF is. Doesn't this make much more sense looking at that scatter plot? Yeah. Kind of disappointed in CPM, to be honest with you, right now, because I feel like that should match and give you some like confidence that that should match. I don't know why their numbers don't match. Okay, so at this moment, I'm gonna go up to the problem, see if it makes sense to just answer the question. Yes, of a linear relationship relating amount of fertilizer to yield per plant. Easy peasy. I like it. You take two numbers and divide them and then do TCDF. Just remember to multiply by 2. I have one last joke for you. Are you ready for it? Your very last joke. Mm-hmm. 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 Good one. It's a good one. So don't get your calculator stolen the day before, please. Quick note, they will have a bank of calculators down there. Yeah.